Today we're going to look at section 5.2, graphing polynomials. Our objectives are to be able to graph a polynomial from its factored form and to be able to find the degree, maximum number of turns, the left and right end behavior, and the y and x intercepts in order to graph. So what is a polynomial? Well, first, a polynomial is just a monomial or the sum or difference of monomials, okay? And you guys have been dealing with monomials for a long time. And if you look at the bottom, a monomial is just a variable, a real number, or a multiplication of one or more variables, and a real number with whole number exponents. That's the important thing, is that we're not going to have any weird exponents. Okay, and if you remember what a whole number is, it's 0, 1, 2, 3, 4, 5, 6, and so on. So what we're going to be dealing with, for example, is x squared. That's an example of a monomial. I could put a -3 in front of it. That's a multiplication of a variable and a whole number. It has a whole number exponent. That's a monomial. But as soon as I add something else to it, say 4x, this is now a polynomial. Poly meaning multiple. Okay, so I have more than one monomial. So what we're going to be dealing with today is graphing a string of these together, which we call polynomials. So in order to graph a polynomial, a couple things have to be true. One, it must be a continuous graph. So what that means is if I have a basic graph, that means that it has to be continuous. So whenever I start graphing, I have to be able to just continue with my pen all the way across. Okay, I can't have any breaks, so that would be continuous. What would not be continuous is if I erase part of this. Okay, so if I erase just a tiny little part of this, okay, so something like that, and put a dot, okay, if I stopped it at some point, that would not be continuous because I'd have to pick up my pen to go and finish it. It must also have smooth curves. So what that means is that if I curve, it has to be nice and fluid. Okay, that is good. What doesn't have smooth curves is something like this. So our absolute value graphs are not examples of polynomials because they have this rigid point. Okay, a quick turn, not a smooth curve. Okay. So how do we determine the maximum number of terms? It is always one less than the degree of the polynomial. So what is degree? So if I look at a polynomial, so let's go back to, we have 3x squared plus 4x. Okay, the degree, if we put it in descending order, okay, is going to be the value of our largest exponent. Now we're not going to be dealing with any polynomials with x's and y's in them, so to make it pretty straightforward. But if I have 3x squared plus 4x, this would have a degree of 2. If I had, say, for example, negative 7x to the 5th plus 2x minus 1, this would have a degree of 5. Okay, so this one would have a maximum number of 1 turn. This would have a maximum number of 4. Doesn't mean it has to have that many, but that's the maximum number of times I can physically change direction. So basically from going down to up or up to down. So the next thing we're going to talk about is the left and right end behavior. So what that means is, what does the left side of our graph, our left arrow that goes on forever, do, and what does our right one do? So if we look at this, it all has to do with our lead, basically our lead term. So I'm going to give you a couple examples. If our lead term is, say, 4x to the 6th power. So if we have 4x to the 6th power, okay, this is positive. Okay, I have a positive lead coefficient, and my degree is even. Okay, if that happens, the positive tells me that the right side of my graph is going to go up. It's even, so what that's going to tell me is that the left side is going to do the exact same thing that the right side does. So my graph is going to wiggle and do a whole bunch of stuff in between, but the left side and right side are going to face up. Well, what happens if I take that same thing, but I make it negative 4x to the 6th? Well, okay, my lead coefficient now is negative, but I still have an even power. Okay. Well, because it's negative, that tells me that the right side is going to go down. Okay. And because it's even, that means the left side is going to do the exact same thing. So our graph is going to do a bunch of wiggles in between, but I know the right-hand side and the left-hand side are going to face down. Okay. Let's give another example. What if I have 4x to, say, the 3rd power? So I know right now I have a positive lead coefficient, but I have an odd degree. Because it's positive, I know the right side is going to go up, and we always deal with what the right-hand side does with the positive and negative. But because it's odd, the left side is going to do the opposite. So since this one goes up, this one's going to go down. Okay, odd is opposite. Helps you remember its opposite. So what if I have a negative 4x to the third? If I look at that, this is a negative value and an odd degree. Because this is negative, I know my right-hand side is going to go down. And because it's odd, the left-hand side is going to do the opposite. So again, I'm going to have a bunch of wiggles in between here, but knowing the left and right end behavior is going to be very useful in graphing. So now we're going to talk about single, double, and triple roots. Okay, and these are going to be very important when trying to know, especially when our graph is given to us, our function is given to us in factored form, what happens in between our left and right ends. So what if we have a single root? So let me give you an example of a single root. It's going to be anything that's x plus or minus some sort of number. So let me give you x plus, let's say, 2. Okay, and it's called a single root because it has this imaginary 1. It's to the first power. Well, if I have x plus 2 as one of my factors, I know that x equals negative 2 would be one of my solutions or one of my zeros, or sometimes called a root. So if I go to negative 2, I can put a point. I'm going to do that for all three of these. I'm going to have x plus 2, but now this is going to be a double root, so it's going to be squared. And I'm going to use x plus 2 for the triple root, so I know it's going to be cubed. Okay, so what that tells me is that I know I'm going to have a solution, a 0, at x equals negative 2. So I'm going to do that for all three of these. So what we're going to compare is what actually happens at that root site, at that negative 2. Anytime we have a single root, okay, this is looked at as a linear function, right? X plus 2 is linear. So that means at some point we're going to just go through it. I don't know if it goes through kind of a positive slope or a negative slope line, but I know that when I graph, it's going to just cut straight through. So if I took a little snapshot, a little picture right at negative 2, it's going to look like a line. If I have a double root, okay, when I take a little snapshot at negative 2, it's actually going to look like a parabola because we know x plus 2 squared, if I was to graph that, would be the shape of a parabola. So I know that if I just look at negative 2, it's going to look like a parabola, so it's going to bounce off that. Now, it could have bounced from the positive side or the negative side, but it's going to look like a parabola because it's a double root because it's squared. If we have a triple root, now we haven't spent much time talking about what cubics look like, and we're going to spend a lot of time at the end of the chapter, but a cubic, if you graph x cubed, either looks like this, negative x cubed looks like that. So what's going to happen is if I take a little snapshot at negative 2, it's going to look like it's going to curve like a parabola. Okay, it looks like a parabola like a second root, but instead of curving back down, it's now going to curve up. So I kind of think about it as one side of a parabola and another side. It's not exact, but it might help you in graphing it. So that's what a single root looks like, a double root, and a triple root. Now these could be facing, this could be facing in a negative direction, or a negative direction, but we'll know that more from the problem. So we're going to go through three examples. Our first one is f of x equals x minus 3 times x plus 5 times x minus 5. So I'm going to give you everything in its factored form because it'll make the problems a lot easier. We're going to spend time at the end of the chapter starting in an unfactored or standard form and then converting it to this form. But since we don't know all that stuff yet, we're going to start here. So how am I going to know what degree this is? Okay, and degree is what it looks like if I was to distribute, or you guys might say FOIL this, and then distribute again. If I distribute all this out, what would my largest exponent be? Well, I can tell you right now that if I multiply these together, my highest exponent is going to be x squared. If I take an x squared and multiply it by an x, I know I'm going to get an x cubed. So I know at some point I'm going to have an x cubed as my largest variable, my largest term, so my degree would be 3. Which means my maximum number of turns is always 1 less than this. So that means I'm going to have no more than 2 turns or 2 changes of direction in my graph. Now I want to know, what does the left and right end behavior do? Well, remember, this is x cubed. So how do I know if it's positive or negative? Well, if I look at my x's, I have a positive x, a positive x, and a positive x. So I know that this is going to be a positive value, a positive x cubed. So when I look here, because it's positive, I know the right-hand side goes up. because the degree is odd, I know the left side is going to do the opposite direction. So I know my graph is going to go down to the left or fall to the left and then rise to the right. X-intercepts. If you remember, x-intercepts are when y is 0. Well, if I put 0 in for our y, or f of x, hopefully remember there's zero product property, and we've dealt with this with solving by factoring, that I can set each of these factors equal to 0 and solve for the x value. Well, hopefully you can see that this is going to give me a 3, 0, a negative 5, 0, and a positive 5, 0. Okay? And my y-intercept is what I get when I substitute 0 in for x. So if I put a 0 in for x, I'm going to get a negative 3 times a positive 5 times a negative 5. Well, that's going to give me, I know 5 times a negative 5 is negative 25. A negative 25 times a negative 3 is a positive 75. So I'm going to get 0, 75. I'm going to get to increasing and decreasing here in a second after we graph it. So how do we even start this? Well, I'm going to start by plotting all my points. I know I have a point at 3, 0. Okay, 1 at 5, 0, and negative 5, 0. Okay, and then my y-intercept is extremely high, which is fine, so just put a line up here somewhere. Okay, this is 75, and I'm going to put a point. Okay, here I don't have to put numbers because I physically put out the tick marks, so I know that this is at 3, 5, and negative 5. Now, I know the right-hand side goes up, so I'm going to go to my furthest right point, and somewhere up here I'm just going to put a little arrow, because I know that I'm going to go up from this point. I'm going to go to my leftmost point, and I know somewhere from here I'm going to go down. So I'm going to put a little arrow going down. So now what I want to know is what kind of roots are these? Well, if I look here, each of these would have an imaginary exponent of 1, so those will all be single roots. So I'm just going to do this to help us. I know this is a single root, single root, single root. If it was a double root, I'll put 2 lines. A triple root, I'll put 3, just to help remind me. So now that tells me that if I take a little snapshot right here at my negative 5, it's going to look like a line. So I'm just going to go straight through that point. So it's going to look like a line. So what's the next point I come to? Well, the next point I come to is a 75. So at some point I'm going to have to come through and hit the 75. But now I have to get all the way down to 3, so I'm going to have to turn and start coming down towards that. Now I don't know if it turns exactly here, and remember this is just going to be a light sketch, so my goal is just to get a rough estimate of what this looks like. So now I need to go to this 0. Okay, this is 3. What kind of root was it? It was a single root, so I'm going to put a line through it. So it's going to go straight through, so if I took a little picture here, it looks like a line. But now I need to get through here, so what do I need to do again? I need to turn. So I've turned once, and now this is my second turn. I know this is the most number of turns I can do anyways. And now at 5, 0, this is also a single root, so it's going to go straight through, and then I end facing up. So that would be a light sketch of what our graph would look like. Now it might not be the prettiest. I don't know if it turns above and then comes down through 75. If it goes through the 75, most likely it would go up, turn, and then come back through the 75. But you can go straight to it because again it's just a light sketch. So what do I mean by increasing and decreasing? Okay, and we're going to talk a little bit more about this later when we actually use the calculator for it. But I know I'm increasing, okay, anytime my graph is going up. And we talk about going from left to right. You're going to deal with a lot more when you get to pre-calculus, but I just kind of wanted to give you an idea of what's happening. So I know that I'm increasing to some point, going up, and then what I mean by decreasing is where I'm coming down, and then I increase again. So we're going to increase and decrease at these maximum and minimum points. And I don't know where the maximum point is up here, but I just want you to kind of start thinking about that this graph goes up and down and up, and that's how we get our turns. We increase, when we go from increasing to decreasing, that's a turn, and we go from decreasing to increasing, that's another turn. So we're not going to fill this out right now, but I just want you to start thinking about that, and that'll help you with the number of turns. So let's look at our second example. F of x equals negative x squared times x plus 2 squared. So what's the degree here? Well, this isn't all multiplied out, but I know I have an x squared here. I know if I was to FOIL or distribute x plus 6 squared, I'd get x squared plus 12x plus 36. So I'd have an x squared and another x squared, which means I'm going to have x to the 4th power. And I know this is negative, and a negative times a positive is a negative. So I have a negative x to the fourth. So that means my degree is 4. 1 less than 4 is 3. Okay. Now, I need to know the left and right behavior. Well, negative tells me the right side goes down, and because the degree is even, that means the left side does the exact same thing. Now, how do I find my x-intercepts? Well, again, if I put 0 in for y, I already have my factor, so I'm going to set each part that has an x equal to 0. So if I set negative x squared equal to 0, I know x equals 0. And if I set x plus 6 squared equal to 0, I'm going to get negative 6. Because remember, even though this is squared, if I take the square root of 0, I still get 0, so it doesn't really factor in too much as far as changing my answer. Now I need to find the y-intercept. Well, I know the y-intercept is when x is 0. If I put in 0, I get 0 times 6 squared. Well, 0 times anything is 0. And just so you know, anytime you have 0 as an x-intercept, it must also be a y-intercept, because 0, 0 is both an x-intercept and a y-intercept. Okay, so we're going to go through like we did before. I'm going to plot a point at 0, 0. One at negative 6, 0. Okay, and then here's 0, 0 again, so I don't have to worry about it. I know I'm going to go to my rightmost point, and I know after that it's going to face down. I'm going to go to my leftmost point, and I know after that it's going to face down. Okay, so I need to know what happens in between it. These are the only 2 points that I can touch or go through on the x-axis or y-axis. I can't cross through at any other point, so my graph will never cut through anywhere that I don't have one of these points. So what kind of root is the negative 6 and the 0? Well, this 0, where I got 0 from, is a double root. Okay, so I know this is a double root. I know this negative 6 is a double root. Okay, so that means when I get to the negative 6, it's going to look like a parabola. So that means when I hit this, it's not going to go through it like a line. It's going to bounce off of it like a parabola. So this would be my first turn, because I'm increasing, and now I'm decreasing. But I need to get through this point. The only way I could do that is to turn and come back up. So since I was decreasing and now increase, this is my second turn. I only get one more turn, a maximum one more turn. What happens when I get to 0, 0? Well, it's got to bounce off of it like a parabola. So I'm going to come up to it. It's going to hit this. It's not going to go through like that. It's going to bounce and then come back down. So here is my 1 turn, 2 turns, 3 turns. And I know I have double roots at each, because if I take a little snapshot at each of these zeros, it kind of looks like a little parabola. Okay? And let's look through our last example. So now I'm actually kind of going in reverse order. I'm going to give you the graph. And these should have arrows. The computer doesn't do it. Find the factored form of the given graph if we assume that it has a lead coefficient of 1 or negative 1. Okay? The 1 will tell us if our lead coefficient is positive. Here, a negative 1 would be it's a negative, and we could tell that by looking at the graph. So we want to know the degree, maximum number of turns, left and right behavior, and our x-intercepts. So what would be easiest? Well, left and right behavior should be pretty easy. I know the left side goes down, the right side goes up. So right now, because the right side goes up, I know that my lead coefficient has to be a positive 1, not a negative 1, because the right side only goes up when the lead coefficient is positive. The left side does the opposite. So since it does the opposite, I know my degree has to be odd. Okay? So if my degree is odd, I know my maximum number of turns is going to be an even number, because 1 less than an odd number is going to be an even number. X-intercepts, I can tell by looking at the graph. I'm going to have one right here at negative 4, 0. I have another one here at 2, 0. And I have another one here at 6, 0. But now I want to know what kind of roots are they. If I look at negative 4, it doesn't go through like a straight line. It curves like it's going to be a parabola, but then it curves back up. So this is actually what we call a triple root. I'm just going to put a 3 lines on it. You can put a 3, you could draw a triple, whatever you like. If I look at 2, okay, if I just take a little snapshot here, it actually looks like a line, like it goes straight through, so that's a single root. And if I look at 6, it kind of, if I take a little snapshot, it goes straight through, so it's a single root. So let's count the roots. 1, 2, 3, 4, 5. Well, there's my odd number. The degree actually tells you how many roots you're going to have. So let me go back for a second to those other 2 examples we had. 1, 2, 3, 4 roots, I had a degree of 4. 1, 2, 3 roots, I had a degree of 3. And that will always work out for you guys. So 1, 2, 3, 4, 5 roots. There's my degree of 5, which means I have a maximum number of turns of 4. So let's think. I'm increasing. That's 1 turn. Now I start to decrease, but then I start to increase again. So this is 2 turns. Doesn't really look like it, but it's 1, 2, 3 to come back down, 4 to go back up. So now I'm going to take all this information and write my factored form. Because it's a positive 1, I know I have a lead coefficient of 1. And if I have if I have a negative 4, 0 as a 0 or an x-intercept, that means x plus 4 must have been my factor. Because if I set this equal to 0, I get negative 4. But it's a triple root, so I know it's cubed. If I have 2, 0, that means x minus 2 was a 0, but it's a single root, so it's the imaginary first power. And then 6, 0 gives me x minus 6. Again, it's to the first power. So this would be the factored form. And the order that you put these in does not matter, as long as it's a plus 4 to the third power, a minus 2, and a minus 6. Okay? Hope you feel a little bit better about graphing polynomials, that you feel that you're able to graph it from its factored form, and to be able to find the degree, maximum number of turns, left and right end behavior, and the x and y intercept.